Morning, everyone. We'll go ahead and continue where we left off last time. We are still in section 4.2. 4.2 was the graphing of polynomials. We talked about polynomials yesterday and some of these characteristics here. So we're going to kind of continue with that with this problem here. So we want to do negative 2x cubed and then times x plus 2. Now, when you do these problems in my open math and also for a test, you're going to have the correct number of blanks for how many zeros and multiplicities there should be. So for instance, this one here has got two different factors. There's two different zeros that you have for it. So you always will know exactly how many blanks to fill in depending on what you have for that. So that's how the problems are going to be set up for us. So for each of these, we want to set each factor individually equal to 0, and that's going to get our answers right here. So if you take 2x cubed and set it equal to 0, then what you're going to get is you will just get a 0. Okay, so if I put a 0 into here for x, the whole thing's going to turn into a 0, so I have that. The second one, the part that makes this part equal to 0 is going to be negative 2. Now I want to get the multiplicities that are attached to each of these factor pieces. The first one on the x, there's a multiplicity of 3. And on this one, there's no power up here, which means that has a multiplicity of 1. We talked about this yesterday. If you have an odd multiplicity, the graph is going to cross. And if you have an even multiplicity, it's going to touch. So both of these are odd. And so that means that the graph is going to cross at each of these zeros. All right, now next thing is the degree. You can get the degree by adding up the multiplicities. So if I add that together, 3 plus 1 is going to give us a 4. And then the max number of turning points is always 1 less than the degree. We talked about that yesterday, and so that's going to be a 3. Now for the y-intercept, so if I do, so y-intercept is where I put in a 0 for x. And if we do that, we're just going to get a 0 again. So by putting that in there, because this part's 0, 0 times anything is 0, so the whole thing is 0. Therefore, your y-intercept is 0. Specifically, what that means is the graph actually crosses through the origin there. It crosses through at 0, 0. And it's also going to cross through at negative 2. So that's our intercepts that we have on the graph so far. But we have to figure out, does the graph come down or does it come up? We don't know that until we talk about the power function and also the end behavior. Now this one is easy enough to where I'm just going to go ahead and multiply that out for us. So if I multiply this one, I'm going to get negative 2x to the 4th. And then minus 4x cubed. So this blank right here, if it asks for the power function or what the graph behaves like, we're just going to take the term that has the highest power. So the one that has our degree, it's negative 2x to the 4th, and that's the term I want to look at. That's also the term I'm going to look at for finding the end behavior. Okay, so let's talk about end behavior next, and now we could put this on the graph. So end behavior, we've got, all right, so for this, the n is even because the highest power, the degree is even, okay? And then the a of n is the number that comes in front of the x with the highest power. In this case, we have a of n is less than 0. We got to go look at the chart that we talked about in the previous section. And so if we do that, that means that this is the model that we have. It's going to basically open, may do some stuff in the middle here, but it's going to go down and it's going to go down there. So I know about this is that each of these here, that's going to go down. And then this will go down as well. So both of them go down. So first I'll start off with this piece. Now I know that the graph is going to cross here. because we said that the multiplicity is odd, so it's going to cross. So that's going to cross here. It's going to go up to a certain amount, and then it'll start to go down. Now, before we go ahead and just draw the line straight through, one thing we have to look at here is at the 0, that has a multiplicity of 3. So this is the term, when it crosses at 0, it's going to kind of resemble a cube-shaped graph. So that's one little detail I have to focus on. Now, the ones I did yesterday had squares on them, or just an X. So just cross through as a line, or it looked like a parabola. Because this has a cube here, that means I have to actually make this look like a cube. So when it comes down, I'm actually going to put a little bend in it and have the graph come down and look like this. Again, the only reason why I'm doing the bend in there, you only want to draw that bend if you see that you have a cube. Okay, so if you have a cube in there, that's when you want to bend it like that and make it a bend in the graph like this. All right, so it goes up. We don't know how high it goes up to. Again, we're not looking for that detail. But then it's going to come back down and it's going to bend in the graph because of the cube. So you only have to worry about the little bend in the graph is if you have a cube here, then you have to deal with that. Notice that this other one where it crossed at -2, we don't have a cube there. The reason why is because the part where the -2 came from, this is a linear function because all this is raised to a power of 1. So when it crosses at -2, if we just look at this piece, that's just x plus 2, which means it's resembling a straight line that we have. So it's a linear fashion. It won't necessarily be the equation x plus 2. It's not necessarily that, but it's going to be something linear because there's a 1 here in that case. For the ones that we did the other day here, I'll go back and I'll kind of review that for you as well. This one right here that we did yesterday, each of these multiplicities is a square. So we can see each of these pieces, they're both squares. So that's why they both look like parabolas as they cross each of those. Now, it does that normally just because of the shape, because of the end behavior we found. That was the only way that could have behaved that way. But that's why, because they resemble squares. The first one we did was, this is all ones. So everything here is everything all linear. That's why all these just cross through and just look like regular lines when they cross through. So really the only one we have to be concerned about is if we have a cube on there, and then the cube is going to resemble this little bend shape. And it's not going to go the other direction because of the direction we're coming, because it's the end behavior, we have to come down. We know it crosses, but it'll have to curve, and it's coming through this way. So that's why I'm putting the bend like that. So that's why we have to be a little bit concerned on this one because of the cube that we have. The next example is going to have a cube also, and so we'll take a look at that one as well. Now, this one is probably the most complicated one you'll see of this type because we've got 3 different zeros we'll have to find in multiplicities, and we also got some decimals. Now, for this problem, because there are decimals that are in here, I'm actually going to do the entire problem working with decimals. So that's okay to have decimals as part of your answer, and also for the behavior and things like that. So let's go ahead and look at each piece. Now, this first part, x cubed, if I set x cubed equal to 0, I'm going to get a 0. The next piece, the part that will make this equal to 0 is going to be 1.5. And then this one, it'll be negative 1.5. Okay, so those are going to be your x-intercepts or your zeros. Now, multiplicities would be the little powers that are on each of these factored pieces. The first piece, we have a multiplicity of 3. Then we have, the next one is a multiplicity of 2, and we also have a multiplicity of 2. If it has an odd multiplicity, it's going to cross, but because these other multiplicities are even, it's going to touch at those places. So where it crosses at 0, it's going to look like an x cubed graph, and where it crosses at these other decimals, it's going to look like parabolas. Okay, so we kind of have a little idea what the graph will look like ahead of time. If one of your zeros is a 0, then automatically your y-intercept is going to be a 0 as well. The reason why is the y-intercept, you want to put a 0 in for x, and if you put a 0 in for x here, it's just going to make the whole thing 0. So that y-intercept, so if you have a 0 on any of these blanks up above here, you automatically have a 0 for the y-intercept. That means the graph just crosses through the origin 0, 0. Now the degree, we find the degree by adding up the multiplicities. So if I add these up, 3 plus 2 plus 2, that's 7. So degree is 7. The turning points is always 1 less than that. So the maximum number of turning points is 1 less, so it's 6. Okay, so we got all that. Let's go ahead and put these points on here. We got 0, 0. We've got a positive 1.5 and negative 1.5. So we have those right there. Now, next thing we want to figure out is what kind of behavior this is doing. In order to do the behavior, we have to know what the power function is. Now, the way that we're going to do this is if you take a look at each piece here, and we're going to ignore the decimals that are here. I'm just going to look at the x values only. What I have essentially is I have an x cubed. There's no number in front of that. It's just a 1x cubed. If I multiply this part out with the parenthesis, I'm going to get a 1x squared something. So I'm going to get a x squared, and then some decimals I'll have with that. If I multiply, I don't have to multiply all that out, but I know if I multiply it, the highest power I'll get when I multiply just that middle term, it's going to be x squared. And then this the last factor I have, I'm going to get an x squared from that as well. Now there's a 1 in front of the x, and there's a 1 in front of the x. All these have 1s in front. So I have basically this I'm multiplying together. When you multiply those, you're going to add the exponents. So you get x to the 7th power is what we get as a result, which makes sense because the power that you have on the power function should be equal to your degree, which it is. So x to the 7th. So basically this says if I were to expand and multiply all this stuff out, I would get x to the 7th power would be the leading term there. I wouldn't have any other number. There's no other number in front of that because if you look at what you're multiplying, all those have 1s in front of it. So 1 in front of this, a 1, and then the 1 there. So you don't have to expand and multiply all that out because that's going to take a long time to do. You don't have to do that. Just look at the highest powers you're multiplying together, and that's going to tell you your power functions. The graph's going to kind of behave like an x to the 7th graph. Now, because of that, what that's going to tell us is that so now let's look at the end behavior. Okay, so the end behavior, n is odd this time. Okay, degree was 7. Now the a of n is the number that comes in front of the x to the 7th. We determined that's going to be a 1 because everything we're multiplying together was a 1. So we have that a of n is greater than 1. So if n is odd and I'm sorry, greater than 0. Okay, so if n is odd and a of n is greater than 0, then it's going to look like this. Okay, so that's the model that it's going to resemble. It's going to go down and it's going to go up. Might do some stuff in the middle, but ultimately it's going to go down and go up like that. So let's put this together and do the graph. So I know that, okay, so at the decimal, it's going to do it touches at that point. So the graph is going to come up from here because the end behavior, but the graph needs to bounce. It needs to go down like that, okay, because it touches. And then it's going to curve. Let me make that look a little bit narrower here. So it's going to go down. Again, I don't know how far down it's going to go to. I need calculus for that. So we're just doing an estimate here. It's going to go down to that point. Now, I mentioned that at 0, the multiplicity is at 3. We know it crosses, but there's a cube that's there. So I need to make this look like a cube when it crosses through. So let's go ahead and do that. And I'm going to put a little bend in the graph like this. Okay, so it's going to go down. We don't know how far down it goes, but when it curves back up, it's going to have the bend in the graph like this because it's the x cubed graph that you have. Then it's going to go up to, I don't know how far up it'll go, probably about the same as this one though, so let's make it look like that. It's going to curve, and then again, when it hits 1.5, it touches there. That means the graph has to do another bounce again and go like that. All right, so and then also notice that at 1.5, negative 1.5, it resembles a parabola or upside down parabola because we've got squares on the original equation that you have with that. So this is what the final graph is going to look like. So it comes up from here, it bounces, goes down to, again, we don't know how far down exactly this goes, but it'll curve back up and go through here. And when it does, it's going to have the bend in the graph because of the cube, because the x cubed tells us that. Goes up to around the same amount. We don't know exactly how high, and then it'll just come back down and do that. So that would be your graph. So again, the ones that you're going to do on a test and also in the homework could just be a multiple choice. So then you can just go ahead and select the correct graph from that, and that would be your final answer. Okay, so that's actually the last problem in 4.2. That was a little bit more complicated one for us, but that was basically it. So you're using your intercepts, you're using your end behavior. That's what you're using in order to draw these, and also the idea of whether it crosses or touches when you take a look at the multiplicities here. Okay, so let's move on to the next one. Okay, next section. Now we're skipping the 4.3 and 4.4 because that has to do with rational functions, and we're going to cover all of that on the next test. So we want to stick with the polynomials, and so we're going to talk about polynomial and rational inequalities. So we are going to briefly talk about rational functions here, but we're not going to really do anything with them. We're just going to talk about these inequalities. And so these kind of problems are having us solve equations where so there's still going to be polynomials, but you'll have greater than or less than or equal to 0. You'll have something like that. So there are inequalities with polynomials or with rational inequalities that we'll talk about a little bit later here with that. So the first couple of questions that we're going to do here, now it might be hard to see what this graph here, but this here is at -1. That's -1 right here, and this crosses at 5. So at this point, it's going to cross at a 5 for right there. And so we want to use this graph that's provided. So the graph comes up from here, and it goes like this. So I'm just going to go ahead and darken this in because when it comes out with the video, this may not be that clear. So I'm just going to go ahead and fill all this in for you so you can see. All right, so this right here. All right, so this is what it looks like. It crosses at -1 and 5, and it looks like that. We're solving inequalities. Now, what this means is that you want to do a part A and a part B, and so they're going to give you a similar thing like this in the homework. For part A, this is asking us to solve. So this curve that we have here, this is actually that's f of x. That's the graph. So you want to solve for when f of x is greater than or equal to 0, and also when it's less than 0. Now, greater than or equal to 0, the 0 represents the x-axis. So when it's asking you to solve f of x is greater than or equal to 0, it's really asking you for what part of the graph is above the x-axis. Okay, so right here, it's really like above x-axis. That's what that asks you for. Make that look a little bit neater so you can read it. Okay, so above x-axis, and this means below x-axis. All right, so we got above and below each of those. So part A, we want to indicate the interval the interval for which the graph is above the x-axis. Now we only see the graph is, now it says either above the x-axis or equal to 0. Okay, so first of all, we've got this piece right here. So I've got the interval. Now I have to put a bracket because I've got a greater than or equal to. So I want to include the 5 here. So I'm going to do 5 to infinity, and that's going to be the interval for this section right here. It's 5 and above. However, there is one more piece that we have here. The graph, notice it says f of x equals 0. Well, it equals 0 at -1 also. So what I'm going to put here is I'm actually going to do this. It's going to be the interval notation from 5 to infinity, but also I'm adding just the x value of -1 only, just the set of -1, because greater than or equal to 0 means that you have to include any point where the graph is equal to 0. Now it's equal to 0 at both -1 and 5. The 5 is automatically included in my first piece I have here. That's the interval from 5 to infinity. So any x value beyond 5, the graph just keeps going up forever. So that part of the graph will be above the x-axis from the x value of 5 and beyond. But it's also equal to 0 at this value of -1. So what I have here is I really have both of those that I have to consider there. So that's part A. Let's do part B. Part B, you're looking for the graph that is below the x-axis. So that's actually going to be all of this right here. Now it's incorrect for us to put -infinity to 5. The reason why is because we already set up here in part A that -1 is where it equals 0, but this says less than, but not equal to 0. So I have to break this up into two different intervals. I have to go from -infinity to -1, and then I'm going to go from -1 to 5. I have to break it up at the 1 because -1 was included up above where it's greater than or equal to 0. That's why I'm not including it down below here. So all the x values from -infinity, -1, the graph is definitely below the x-axis. I'm skipping over the -1. I'm not going to include -1, but then between -1 and 5, the graph is below. And again, I'm using a parenthesis here because I don't want to actually include the 5 because the 5 was already included up above because it's the greater than or equal to 0. So this is going to be your answer. Just grabbing those and reading them directly off of the graph itself, and that's what we're doing there. Okay, so that's your answers. Let's also, next we're going to move on and do the same thing, but we're gonna use what's referred to. This is actually going to be a rational function. Rational functions have what these red lines that you see here, those red lines on there, those dotted lines. The dotted lines represent what's referred to as vertical asymptotes. So whatever this function actually is, if we take this and divide something by 0, that's what happens. You end up getting these dotted lines that occur. So this right here would be an example of a rational function. Again, we're going to talk more about that on the next test. Here, we're just talking about reading values off of a graph at this point, but we'll actually get into how you find the asymptotes and all the other characteristics. We'll talk about all that. That's going to be for the next exam that we'll have. So here, we're still just going to be reading values off of the graph like that. So let's go ahead and do each of the parts now for that. We've got the first one. So let's go ahead and make sure I'm at the right spot here. Going back over to here, we have greater than 0. We're looking for the part of the graph that's above. Now, right here at this point, I'll label this. This is, oops, make that clear. This is -3, where there's a dot right there at -3. Okay, and then this right here, this dotted line, it might be hard to see, but that actually goes through a half. Okay, so that dotted line right here, that's at x equals 1/2. Okay, so that's this dotted line. This other one here, that one's going through at x equals -6. Okay, so x equals -6 there. All right. Next thing we're going to do is now we have that labeled. We want to do f of x is greater than 0. You're looking for the part of the graph that is above the x-axis. Now we have two places where that occurs. You've got this between the left dotted line and up to -3. That graph is above the x-axis. So let's go ahead and write that. It's going to be from, now -6 is not included, -6 up to -3, but I'm going to have a parenthesis on that. Again, we don't want it to actually equal 0 at that point, so I'm not including the -3 there. Okay, from -6 to -3, the graph is above the x-axis. Now another piece where it's above is this section to the right of the right dotted line here at 1/2. Okay, so I'm going to do a union. It's going to be 1/2 to infinity. Okay, so we're at dotted line 1/2, and that goes all the way to infinity there. All right, so B is going to be where it is less than or equal to 0. So you're looking for the part of the graph that is below the x-axis. So here is a first piece. We've got something to the left of that dotted line. So we have from -infinity up to -6. Now, you might be wondering, well, why aren't we using a bracket because it's a less than or equal to? Well, the reason why is because with these asymptotes, the graph is actually never going to reach that point because that's where we have division by 0. That's what makes the rational functions a little bit different. So in this case, I'm going to put -infinity to -6, but that's going to have a parenthesis because, again, at the dotted line like that, we can't actually include that dotted line at all. So it always has to have a parenthesis on it no matter what. So -6, but then union. Okay, now there's another part of the graph that's below the x-axis, and that's from -3 up to the dotted line up to the 1/2 line that we have there. Okay, so this is going to be now -3 this time. That's okay to include a bracket. I'm including a bracket because at that point, the graph, the y value at -3 is 0, and we do want to include that because it's got the equal sign underneath in the original one. All right, so I have -3, and that's going to go up to 1/2. And again, I don't want to put a bracket on the 1/2 because that's where I have some division by 0 going on there again. So anytime you got these dotted lines, you're not able to actually include that at all with it. Okay, so we have, this will end up being our answer. Got to have a bracket. You do have to have a bracket on -3 for sure. Okay, because there's no division by 0 there. It's an actual point on the x-axis, got to be included. That's why, less than or equal to 0, that's definitely needed there. And so this is going to be your answer. Okay. Okay. Next one. Just realized that my my online notes actually have an error in them. This up here, I didn't include the -1 in my answer, but this is needed. So the written notes that I have online, I'm going to go ahead and correct those because that should also include the -1 after that. So I'll go ahead and I'll fix that. Okay, now the next problems that we're getting into are ones where a graph is not provided, and I just have the equation only, and I want to be able to solve for this. So I'm going to show you two different methods here. The first one is shown, it's what's referred to as a table method, and there's also a number line method, and that's what you would use in order to solve these. So what we're going to do first is, before we jump into the table, we have to figure out what numbers to put in the table. And as you see here, I've got -2 and 5. Now, where those come from is you're going to do x minus 5 equals 0, so you get x is equal to 5, and then x plus 2 squared you're just going to set them equal to 0. Now I know it says less than 0 here, but you're going to just pretend that that's an equal sign temporarily. If you square root both sides, you get x plus 2 equals 0, and so you'll get -2 as a result. So that's the first thing you always do with these kind of problems is, first of all, you just go ahead and set both of them equal to 0. And that's going to allow you to find the numbers that you're going to put on your table. Also, when we get to the number line example, these will be the numbers that go on your number line. Okay, so we have both of those here. Then on the table, notice that we're going to put the two factors that we have. So this must be in a factored form, by the way, in order for us to do the table method or number line method. It has to be factored. Now that we have it, those here, now notice that I've got a square on this factor. The square has to appear on your table. This is the most common mistake I see people making with this, is they just put x plus 2 down and not the 2. Okay, so whatever power is attached to the factored pieces, that does belong, and you must put that on your table. Now, the reason why we're setting the table up is because we're now going to do a couple test points. Okay, so we're going to test numbers that are in each of these three regions. You'll test the number that's less than -2. You'll test it any number between -2 and 5, and then we'll test any number 5 that's greater than 5. Now, it doesn't matter what numbers you pick, as long as they fit into each of these intervals. Let's go ahead and pick some test numbers. I'm going to test -3 here. And then I'm going to test a number between -2 and 5. Let's just use 0. That's an easy one to try. Okay, so I'm going to test 0. And then here I'm going to test 6. Okay, so I'm circling these and kind of writing them a little bit below here, because eventually our answers that we're going to pull in here, we're going to find the one that makes a true statement with the original example that we have. And eventually we're reading answers. It's got to be in terms of -2 and 5. We don't want to write answers in terms of our test points. That's why you see me circling these and kind of writing them down a little bit below, because that way they won't interfere with us trying to grab the answers off of here, -2 and 5. What we do is you're going to test the number, and you're going to put -3 into the expression on the left-hand side. So -3 minus 5, I get -8. -3 plus 2 squared is going to give us, okay, so inside here is -1, but if you square it, that's going to give us a +1. If I put a 0 in there, 0 minus 5 equals -5. 0 plus 2 squared is going to give us a 4. And then for the 6, 6 minus 5 equals 1, and 6 plus 2 squared is going to give us a 64. Now, I don't really care about the actual number itself. I only care about whether I get a positive or a negative result. So when we do these problems down below later, I'm actually not going to show you the numbers. I'm just going to put whether it's a negative or a positive. I'll just have signs only on here. But for the first one, I just wanted to show you all what you're actually doing. You're plugging these numbers into everything you see on the left-hand side. And then what we're going to do is we're going to multiply these together. Now, again, I don't care about the number that we get as a result. I only care about what the sign value is going to be. If I multiply -8 times 1, I'm going to get a negative. I'll just write that across the top here. If I have -5 and 4, that's another negative I get. 1 times 64 is positive. So my sign configuration I have across the top here is negative, negative, positive. For this, I want to look at, this is how I'm going to determine what my answer is going to be. I want to look at the inequality that was given in the original problem. So if I have less than or equal to 0, I want to look for negatives. If I have a greater than or equal to 0, I'm going to look for the region that has positives. Okay, so on my original problem, Right here, I've got less than 0. That tells me I need to look for the regions that have a negative. Now, because it's less than 0 and not less than or equal to 0, I have to actually split this interval up, because at -2, which is what I have right here, at -2, it's going to be equal to 0. So in that case, I don't want to actually include the number that equals 0, because that's similar to the graph question we did earlier. If you look at the graph of that, it'll touch the x-axis at the -2, but it's not going. But in that case, we don't want to include that because we don't want it to actually equal 0. So what I'm going to put for my answer, I'm just going to describe the region that has the 2 negatives, and I need to write a separate interval for each one. I'm going to go from -infinity to -2. Now again, you want to use the numbers that are on right here. So the numbers that are in the boxes here, those are the ones you want to use when you indicate your answer. That's why, again, I put the test numbers, I usually write them below. If you were to put like -3 right here in the number line, or negative right in the middle on there, you might get confused and grab the wrong number when you're writing your answer. And so that's why for this, we're just kind of writing them down underneath the test values. Okay, so this is going to be -2 to 5, and that's going to have a parenthesis on it as well. And so that right there is going to be our final answer. Okay, and so that's it. So -infinity, -2, and then from -2 to 5, that's our answer that we would put in this case. So you have to pay attention to the inequality sign that's on your equation. If it was greater than 0 or something different, you'd have a different answer because you'd be looking at different regions that are on here. Okay. So I showed this by using the table method, but I also want to do the number line method as well. So with number line, let's rewrite our equation here. We've got, originally we had y equals x minus 5, x plus 2 squared. That was our original equation. Now, a number line method, you're still going to set both of these equal to 0 like we did earlier. Instead of having a table, you're just going to have a number line. So a number line where we got -2 and we have 5 on it. So that's our number line right there. Now we're still going to use test points. So I'm still going to test -3, 0, and 6. But the difference here is we're going to plug these into the original equation. So I'm going to write this out here. Let's test x equals -3. If I do that, I get -3 minus 5. And I have -3 plus 2 squared, and I want to find the y value when I do that. So I get -8, and then times -1 squared. If I multiply that out, I get a -8 times +1, so I get -8. That means that this region is negative. Okay, so I tested out the -3. Let's do another one. Let's down below here. Let's test x equals 0. Okay, so y equals 0 minus 5, 0 plus 2 squared. If I do that, I get -5. And then this is going to be a 4. So I get -20. That's a negative number. Put a negative there on that line. And then finally, we test x equals 6. So I have 6 minus 5. And then I have 6 plus 2 squared. Let's work that out. I get 1 times 8 squared. I get 64. That's a positive number. And I put a plus on here. Now, getting your answers will be exactly the same as what we did before. So this is our equation. Now, originally, again, we've had the original problem. So I did this for purpose of getting y values, but really what I had before was I had x minus 5, x plus 2 squared is less than 0. You know what? Let's actually, just because, let's go ahead and suppose that the original problem I had this time was greater than or equal to 0. Okay, so it's actually let me do less than. It's gonna be a little bit better if I do less than, because I want to show a point that I have to make here. So this I have less than or equal. Now remember, the original problem I had up here was less than 0, but I'm using number line method, and let's pretend that the original problem I had was this right here: x minus 5, x plus 2 squared less than or equal to 0. Well, now if it's less than or equal to 0, that means that the -2 is going to be included. So if I had this, that means what I would put here is -infinity to 5 with a bracket, and that's what I would have for my answer. Notice how different this is from the one I did before. The one I did earlier had less than 0. Less than 0 means you have to include the negatives, but -2 was not able to be included there. However, if you have less than or equal to 0, now the -2 can be included, because if I put -2 into here, I'll get a 0, and that will make this equation correct. Okay, so by that reason, you can include the -2, and therefore you don't have to break this up into 2 separate intervals. Now, yeah, you could actually do -infinity to -2 with a bracket, and from -2 with the bracket to 5, but that's kind of redundant. You want to actually make it concise and just put one interval. So there'll be one interval from -infinity all the way up to and including the 5, and that's what the answer would look like if it was less than or equal to 0. Now, of course, if you had greater than, then you would just be using the plus sign, and you'd have 5 to infinity as your answer if it was greater than 0 or greater than or equal to. It just depends on whether you have a bracket or a parenthesis on the 5, but you still have 5 going to infinity because of the plus sign that you see right there. Now, it doesn't matter which approach that you want to use here. Either a number line method or table method are both going to give you the same answer. So the next problem I'll do, I'm going to show both methods as well. I'll show a number line method and table method again for that. So let's go ahead and do that for this next one. Okay, so let's actually not show the table now and just show you what you would do ahead of time. So if you're given this problem like this, 6x squared less than 6 plus 5x. For a problem like this, what I would want to do first is I would want to bring everything all over and put the 0 on the right-hand side. So the right-hand side is what I want to use. That's why I didn't want to move over and make that negative. Instead, I kept 6x squared on the left-hand side, and I subtracted the 6 and the 5x, and those became negative when you bring them over. Now that you have that, this is something that you want to factor. Now, we did do a factoring problem before. We talked about in the previous section, there's different factoring methods. There's bottoms-up method, grouping method. There's different things that you could use there. I'm going to talk about a method that we haven't gone over yet. And sometimes for certain problems like this, where there's not a lot of factors, you can use what's referred to as a trial and error method for factoring. Trial and error means that you're going to pick factors that will give you 6x squared. So I might want to try 2x and 3x. Now, I might also need to do x and 6x as well. I don't know. I'm just going to go ahead and guess and put in a 2x and a 3x. I'm kind of doing trial by error, so I'm just trying out some different numbers. I have a 6 here, so I have a 1 and a 6 I'll try. And I want to try and multiply this and see if I can get -5 in the middle. Now, if I multiply this, I do get the 6x squared, but then I get a 12 and a 3, and there's no combination of that that's going to allow me to get a -5. So I'm going to get rid of those. Those aren't going to work. Okay, so then I want to try other factors of 6 would just be a 2 and a 3. And so typically you don't have common factors in each parenthesis. So I don't want to put a 2 in here because then I have a common factor. So I'm going to put a 3 here and a 2 there, and I'm going to try that combination and see if that works. Okay, so I get 6x squared, I get a 4, and I get a 9. Now 4 and a 9, if I subtract those, I can get a -5. So in order to do that, I have to put the negative with the larger number and a plus with the smaller one. By doing so, that's going to give me a 4x minus 9x. So 4 minus 9 gives me -5. And then -3 times 2 gives us -6. So I've just done this problem by the trial and error method. And it's okay to use as long as you don't have a lot of factors. If you've got like a 12, 24, something like that, those have a lot of different combinations. So that in that case, you probably want to use bottoms up or grouping method in that case. But for this one, just wanted to show you an example with trial and error. You could definitely do that if there's not a lot of factors. Now we're going to take 2x minus 3 equals 0 and 3x plus 2 equals 0. If you add 3 divided by 2, you're going to get 3/2 here. And if you do the same thing, if you subtract the 2 and divide by 3, you get -2/3. So we get 3/2 and -2/3. So at this point, we have a choice of whether to use the table method or number line method. If we're going to use number line, we're going to put these two numbers on the number line. And also, if you're using a table, you'll have to put these numbers on there as well. You do want to put the smaller number first and then the larger number. If you're going to do the table, this is what the table is going to look like. Notice that we have our two factors. Each of these things, now it doesn't matter what order you put these in. So I have 3x plus 2, 2x minus 3. I got those on there. See, I got these two fractions on here, -2/3. The smaller one goes first and the larger one. Then from here, I'm just going to pick some test numbers to plug into each of these regions, and I'll plug them into the factors that I have on the left-hand side of this column. I have to pick any number that's less than -2/3. I can use -1. Okay, so -1 I'll use. A number between -2/3 and positive 3/2. 0 is always a number that goes between a negative number and a positive number. Doesn't matter what they are. It's negative and positive. You can always use 0. Now 3/2 in a calculator, that would be 1.5. So I want to pick a number that's larger. So I don't want to pick 1 because 1 would not be larger and 1 would still be in the middle region here. So I want to use a 2. So I want to make sure the number that you pick is definitely in that region. These numbers, you're going to plug them into the expressions that you see here on the left-hand side. Now, this time I'm not going to show all the work like I did in the previous problem. Instead, I'm just going to give it the final, if it's plus or minus in each of these. I'm going to plug -1 into here for -x. So maybe I'll just write that below. Okay, so if I do that, -3 plus 2, so that's just a reminder of what we're doing there, and I would do 2 times -1 minus 3. Okay, so that's what I'm doing with the -1. I'm just going to show that step right now, but then I'll erase it because I'm just going to fill it in with the signs. Okay, so that's really what I'm doing though. So let's go ahead and we'll erase that. All right, 3 times -1 is -3 plus 2. I just get a negative number. I don't care about the number itself. I just care about whether it's positive or negative. So a minus. Negative into here. 2 times -1 is -2 minus 3. That's a negative number as well. Then 0. 3 times 0 is 0 plus 2. I get a positive number. 2 times 0 is 0 minus 3. Negative number. Put a 2 in there. 3 times 2 is 6 plus 2 is a positive number. 2 times 2 is 4 minus 3. That's a positive number also. I'm going to multiply these together and put the sign configuration across the top. I get a plus here, a minus, and a plus. That's my final sign configuration, plus, minus, plus. Now, the original problem I have up here, I have another one that happens to be less than 0. That means, again, I'm looking for negative numbers. So I only have one negative region, and that's between -2/3 and 3/2. So for the answer, I'm just going to put I need to go between -2/3 and 3/2. So this is a less than symbol, which means I don't want to include the endpoints. So these are going to have parentheses, but not brackets. Okay, so I got this parentheses -2/3 and 3/2. And that's going to be my answer, the final answer I get on this one. All right, so just describing the region that's a negative. Now, if I were to do this by the number line method, I'd really be doing the same thing. I would be putting in my same test points, -1, -1, 0, and 2. But this time, I'm putting it into the entire thing. So I have so here's the original expression, 3x plus 2, 2x minus 3. Okay, if I have x equals -1, then I have 3 times -1 plus 2, and then 2 times -1 minus 3, like that. I would get -1 times -5, which equals 5, so I would get a plus right there. If x equals 0, then I have 3 times 0 minus 2, 2 times 0 minus 3, and I would get -2, and I would get -3. Multiply that, you get 6. Okay, for that one. And, oh, I'm sorry, this is a +2. This is a +2 right here. Yeah, it's a +2 on the end. I wrote the wrong thing down, so +2. So this is going to be a -6, so you get a minus there in the middle. When you do x is equal to 2, you get 3 times 2 plus 2, 3 times 2, or 2 times 2, and then minus 3. Okay, so this one we get, for this, we get 6 plus 2 is 8, and then we get 4 minus 3 is 1, so we get 8 right there, and that's a positive. Same thing, you just look for, originally the problem was less than 0, so less than 0 means you look for negatives. So again, you just pick the region that has negatives, -2/3 to 3/2, and that would be your answer there. Okay, so next, another one right here. So this one, I have to do a little bit of work before I jump to the table method. For this one, you probably want to have it set equal to 0. So what I would do first is I would do 3x cubed plus 15x squared, greater than or equal to 0. Okay, so let's move that over, and I have this. So now the next thing we're going to do is we're going to factor. So you get 3x squared right there is the common factor you can pull out. There's a 3 that's common, and then at most you can pull out is the smallest power, x squared. So if you pull that out, you're going to get x plus 5 right there. You can always check to make sure you did it correctly by multiplying. You get 3x cubed plus 15x squared. So yes, that is correct. That's the right way that you factor it. Then you would just take each of these, 3x squared equals 0, x plus 5 equals 0, and get the numbers that go on your number line. You get x equals 0 and x equals -5 for that. And as you see here, this is what we have for the table on there. Again, put the smaller number first. -5 has to go first, and then we have a 0. Notice we have our factors on here. There was a square on there, and I'm including the square here on the table. Okay, so I have this. We need to do test numbers on all those. So I need to pick a number that is less than -5. So I'm going to pick a -6. Between -5 and 0, I can use a -1. Any number greater than 0 is a 1. So now these numbers, I need to put them into the numbers here on the left-hand side. Now, if I take -6 and I square it, that's automatically going to become positive. So in fact, if I put -1 into here, that's going to be positive. But if I put 1 in there, that's going to be positive. Okay, so this whole row is going to be positive because when you square something, you're only going to get a positive number. So all these are going to be positive. No matter what number I put in there, if I square it, it becomes positive. Now this makes a difference here. -6 plus 5, that's negative. -1 plus 5 is positive, and 1 plus 5 is positive. All right, so for this, that's going to be the tables are filled in. And so now I want to put across the top what the sign configuration is going to be. I get a negative, positive, positive here. All right, so notice that I need to pick a number that is the regions that are greater than 0. So because it's greater than 0, that means now I am looking for positive numbers. I have two regions that have positives, from -5 to 0, and then from 0 to infinity. So the question we have to ask ourselves is, okay, if I see two regions, do I need to separate them or not? So that's what I need to look at. If you have a greater than symbol, then yes, you do need two different regions. But if it's a greater than or equal to symbol, you only need one interval for this. So the answer I'm going to put here, the answer is going to be from -5. It's going to have a bracket because it's got the equal sign there. And so they go -5 to infinity. We do not have to break this up into two different intervals, because if I take 0, put a 0 into the original one, I get 0 is greater than or equal to 0. That's a true statement. That means that 0 should be included in my answer. I don't have to separate that into two separate intervals. So -5 is going to go all the way to infinity. -5 to infinity would automatically include the 0. Okay, so that's the answer. Bracket 5 all the way to infinity. If that was just a greater than symbol and not greater than or equal to, if it was just a greater than symbol, I would have to split this up and go -5 to 0 and then 0 to infinity. I have parentheses around my answer in that case. Okay. I'm not going to do the number line method on that. You kind of get the idea of it. For sake of time, I want to make sure we'll just focus on one method only on these moving forward. Okay. So here is the next problem that we're going to do. Now, how I got this table is what I did was I actually took each of these separately and I set them equal to 0. So I got x is equal to 2, x equals -1, and x equals 4. You want to go ahead and do that first. So it doesn't matter if the factor is on the top or the bottom of the fraction. Doesn't matter. You're just going to go ahead and take all those individually and set them equal to 0. So each of these, setting them individually equal to 0 there. Then I make the table. I have all the different factors on top and bottom. I put all those in the left-hand side over here. And then this time, notice that I have to put 3 numbers on my table. Notice that I always have one more column than the number of zeros that I have. Okay, so each of these values these values we got, there's 3 of them, but notice I need to put 4 columns on this because you want to include the region before the -1 and after the 4 and all the ones in between. Okay, so that's why you want to make sure you set the table up correctly for that. Again, we're going to use test numbers. You want to pick a number that is less than -1. So we'll try -2. Between a negative number and a positive number, you can always use a 0. Between 2 and 4, you can use a 3. A number larger than 4, we're going to use a 5. Again, notice that I'm writing these test numbers down below. I don't want to put them right next to the other ones because then I might accidentally pick the wrong answer when I do this. Okay, so -2, I just put those in for all the x's here on the left-hand side. -2 minus 2 is a negative number. -2 plus 1, negative number. -2 minus 4, negative number. Then I'm going to put in a 0. 0 minus 2, negative. 0 plus 1, positive. 0 minus 4, negative. Then I'm going to do 3. 3 minus 2, positive. 3 plus 1, positive. 3 minus 4, negative. The 5 minus 2, positive. 5 plus 1, positive. 5 minus 4, positive. I'm going to multiply these signs together to get the sign configuration across the top. Negative times a negative is a positive, but then positive times negative is a minus. 2 negatives make a positive, And then times a positive, you get a plus here. 2 positive times positive is a positive, times a negative is a minus, and 3 positives together are going to give you a plus. So I get minus plus minus plus. We got alternating signs here. If I look up here in the original equation, I have a less than 0. That means that's a minus sign that I need to look for. I need to look for the regions that have a minus on it. All right, so for this, I have this region from negative infinity to -1. I also have from 2 to 4. I'm looking for only the regions that have a negative. So this is what I'm going to put for the answer. I want to put everything less than -1. Now, originally the sign we have was a less than or equal to sign, which means that we can include brackets in our answer. So I'm going to go from negative infinity to -1, but -1 is going to have a bracket on it because of the less than equal on that. And union, here's another region. This region up here had a negative sign in it from 2 to 4. Now this answer that I have here, if I were to put this into my open math, it would actually mark me wrong, okay? I'm going to give you a second to see if you can tell the reason why this is actually going to be the wrong answer. Now, the reason why actually is the fact that this is a rational function, because we've got a x that's in the bottom of the fraction. Notice that if I wanted to find the domain for this original problem, a 4 would cause division by 0. So in this case, I'm not allowed to include a 4 in my answer. So even though I have a less than or equal to here, which would indicate that I would be using brackets for everything, the only time this is an exception is if there's a number that causes division by 0. You don't want to include that. So in fact, the correct answer, you need to have a parenthesis on the 4. Okay, so now it's correct. -1 and 2 are okay, because -1 and 2 don't cause division by 0. If I have a 0 on top, that's all right. 0 divided by anything other than the 0 is fine, because I just get a 0. But there's only a problem if I'm dividing by a 0. That's when we have an issue. So that's one extra thing you have to be careful about when you do these rational problems. That's what makes them different from the ones we did before. Any number that causes division by 0, not included in your domain, not included in the answer. Okay, so this would be our final answer there. We're just looking for the regions that have negatives, and 4 is not included because it causes division by 0. Okay, so this one, I've been kind of jumping back and forth and just doing the number line method only so far. So I want to do the table method I've been using, but I want to jump back and I'll do one this time with the number line, just so you can see the difference. Okay. All right, so this one here, how I got these numbers down below is you probably want to factor this first. So x minus 2, x plus 2 over x minus 3, that's greater than 0. Okay, so each of these pieces, if you set all those individually equal to 0, that's where you get these numbers on the number line from. Okay, so we're not using table methods. I don't have to put these factors on here anymore. I'm just putting the numbers down here only. -2, 2, and 3 I get when I set these individually equal to 0. Okay, then I want to use the test numbers. A number less than -2 is -3. -3, we have a 0 because that's between a negative number and a positive number. Between 2 and 3, I have to use a decimal here. I'm going to use a 2.5. And then a number larger than 3, I'm going to use a 4. Now, we have to test these numbers into the factored problem here. So let's test -3 first. I have -3 minus 2, -3 plus 2, -3 minus 3. I just need to figure out what this is. I have -5 on top. I have -1 over -6. which means I get, so I have 3 negatives here, which is going to turn that into negative 5, 6. So I get a negative sign right there for the first part. Okay. Next, I'm going to test the 0. So I'm going to get 0 minus 2, 0 plus 2, 0 minus 3. Okay, so if I put this all in there, I'm going to get negative 2 times 2 over negative 3. I'm going to get, the negatives are going to cancel out, and I get a positive 4/3. That's a positive number, so I know that's the next region is going to be plus. Then I'm going to test 2.5. Okay, so 2.5 minus 2, 2.5 plus 2, 2.5 minus 3. Now, really, I'm not really concerned about the actual numbers I get here. I'm only concerned about whether I get positive or negatives. So I'm just going to go ahead and write whether I get a plus or minus. So I get plus here, I get a plus there on top, multiplying together, and on the bottom I get a negative result. So that's going to give me a minus sign as a result. So I have plus times plus is plus, divided by negative is a minus. So you don't have to write this whole thing out and get the exact number answer on these. We're just concerned about the signs. Here's the last one. We're going to test 4. 4 minus 2, 4 plus 2, 4 minus 3. Okay, so then I get a, so again, this, I don't even have to work all this out either. I can just do plus times plus over plus on the bottom. All these are plus, so that means I get a plus. Okay, so I have that. So I get minus plus here. Now this problem originally was greater than 0. So greater than 0 means I need to look for plus signs here. That's what that means. So I want to look for plus signs, and I'm going to write my answer. So the answer I'll put down here. Answer. All right, so I've got from, again, this is a greater than symbol only. Okay, so this means I'm going to use parentheses and everything. I'm going to just indicate the regions that have pluses. Negative 2 to 2, union 3 to infinity. Because these are all parentheses, I don't have to worry about division by 0 this time, because the original problem just had a greater than symbol on it. And so that would be the final answer there. We don't have to worry about division by 0 here in this case. Okay, so that's your final answer. All right, this one here, we've got a problem where we don't have a 0 on that side. So now these that don't have a 0, the first thing you want to do is get it to be equal to 0. So I'm going to do x plus 2 over x minus 4. I'm going to subtract a 1, and I have greater than 0. So that's the first step you want to do. On these kind of problems, when you're indicating plus and minus signs like that, you can only have a 0 on the right-hand side. So if it's not a 0, we want to go ahead and do that first. But next thing we have to do is we don't have one single fraction. So we want to actually take this and get common denominators. Okay, so I'm going to take this. I want to try to get this to be one fraction only, because that's how we can break this up and use the number line or table method. Okay, so I'm multiplying the 1 by x minus 4, x minus 4. That allows us now to put this all over a single denominator. So I have x plus 2, I have a minus sign there. I'm subtracting all this. So now let's simplify that. X plus 2 minus x plus 4 over x minus 4 greater than 0. Now the x's are going to cancel out, and we end up getting this. We get 6 divided by x minus 4 greater than 0. So of course, if I take the top instead of equal to 0, I can't get any answer if I set the top equal to 0. But If I set the bottom equal to 0, I'm going to get a 4. So if you want to do this by we'll go back to the table method again. Okay, this is what the table method is going to look like. You have the two factors, a 6 and an x minus 4 on there, but we only have one number on here. We have a 4. Okay, and that's all you have on this one with that. So as far as test numbers, all I have to do is test something less than 4, I'll use a 0. And greater than 4, I'll use a 5. Now you can't plug these into the 6, so this top one all the way across is just going to remain positive because 6 is positive. So we just put pluses across there. But we can plug in the 0 into the bottom one. 0 minus 4 is negative. 5 minus 4 is positive. So we get a minus and a plus situation here for the sign chart. You're looking for the region that is greater than 0. So you're looking for the plus. Okay, well, that's only going to be, the answer then is just going to be from 4 to infinity. Okay, 4 to infinity. It's a greater than symbol. And so because of that, we don't have to worry about division by 0 because it's not going to happen here because we're not including the 4 anyway with it. All right. Now I'm going to go a little bit longer today. I just want to finish the last problem that's in this section. So we have another one that is a little bit more complicated that we'll do, but I want to make sure we have time to do one like this as well. So we have one more where we have to subtract the 2 because, again, we don't have a 0 on that side. So for a problem like this, we're going to take this and we're going to subtract the 2 over to the other side, less than or equal. So we want to make sure you have a 0 on the right hand side. So that's the first step, is just subtract the 2. The second step will be to get common denominators. So I have 2 over 1. I'm going to multiply this by x plus 1 over x plus 1. Okay, so we'll do that next. So I have 2x squared plus 3x minus 4. I'm going to be subtracting this here. So negative 2 times x plus 1. All that is over my common denominator of x plus 1. Then I need to simplify this. So I have to keep going with this here. 2x squared plus 3x minus 4. And I'm going to get minus 2x minus 2. That's all over x plus 1, less than or equal to 0. Want to add the like terms together on this. So I get 3x minus 2x is just plus x. Negative 4 minus 2 is a minus 6. All that's over x plus 1, less than or equal to 0. Now I have one fraction less than or equal to 0. This is the one that you want to factor. So that's why you notice I didn't factor the original problem, because that does not have a 0 on the right hand side. It's only when you have a single fraction, you have a 0 on the other side, that's when you want to go ahead and factor. This one I am going to do again by the trial and error method of factoring. Okay, so I have 2 numbers that multiply to make 2x squared, so I can use x and 2x. And then numbers that multiply to make 6, I can use 2 and 3. So let's try a 2 and a 3 right here. If I multiply this, I get 2x squared, I get a 3x and a 4x. So yes, there is a way that I can get a 1x out of that. If I put a plus here and a minus, that means I'm going to get a negative 3 and a positive 2, or positive 4 will give you a positive 1 there. So negative 3x plus 4x does give you the middle term of 1x. So this is now correctly factored. What you would do after this point is you would set all 3 of those equal to 0 to get your numbers that would go on the number line. So we'll do this one by number line here. So if you take the x plus 2 set equal to 0, you get minus 2. X plus 1 set equal to 0, you get negative 1. You take 2x minus 3 equals 0. You add the 3 divided by 2, and that's where we get the 3/2 from. Notice right here, we've got all three of our factors, x plus 2, 2x minus 3, and x plus 1. All those are in our column. So now we just jump into using test numbers. Okay, so test points, a number less than -2. I'm going to use -3. Between -2 and -1, I got to use a decimal again. So I'm going to use -1.5. I have a negative number and a positive number. You can always use a 0 in that case. 3/2 is 1.5, so I need to test a 2. And I put all these into the pieces on the left-hand side. And again, I'm only concerned about plus or minus signs if I get a positive or negative for each of these. -3 plus 2 is a negative. 2 times -3 is -6. Minus 3 is negative. -3 plus 1 is -3 plus 1 is negative. And -1.5, -1.5 plus 2, that's a plus this time. 2 times -1.5 is -3, minus 3 is negative. -1.5 plus 1, negative. 0 plus 2 is positive. 2 times 0 is 0, minus 3 is negative. 0 plus 1, positive. If I put a 2 into all these, 2 plus 2 is a positive number. 2 times 2 is 4, minus 3, that's positive. 2 plus 1, positive. Now we're going to multiply down each of the columns. 3 negatives is going to give you a negative. Negative and a negative is a positive, times a positive is a plus. You have 2 positives and a negative, you'll get a minus there, and then 3 positives, you get a plus. Notice this time that we have a less than or equal to 0. Less than means we have to look for negatives when we write our answer. If I look at the negatives that's on here, I have 2 regions that have a negative. Now it's less than or equal, which means that I can use brackets, but the only one that I do not want to use a bracket on is the -1, because -1 will cause a division by 0. So all the other numbers, I'll put a bracket on that, but then -1, I need to put a parenthesis on it. Okay, so let's write our answer. Again, we're looking for negatives. We're going to go from, so here's the answer, -infinity to -3. All right, so I have parenthesis here, but there's a bracket that's going to, I'm sorry, not -3, -2. Okay. Again, that's why I kind of write these down below so I don't accidentally grab the wrong number, but that's why you want to do that. So in this case, -2 has a bracket. And then the next one I have -1 to 3/2 is another place where there's a minus sign. Now 3/2 is okay to have a bracket, but I must put a parenthesis on the -1 because that one causes division by 0 in that case. So this would be my answer. All the other numbers, the -2 and the 3/2, brackets are okay, but the parenthesis has to be a -1 because it's division by 0. The other one, of course, we always have parentheses on is if you have infinity and -infinity. Those will always be parentheses because infinity is not ever an exact number. And so that's why we always have parentheses on those. Okay, so with that one now, we have just finished everything in section 4.5. So now we're kind of on schedule here. And so that's going to be it for today. So now we'll just see if anybody has any questions. Otherwise, we'll go ahead and end this meeting. So does anybody have any questions before we end the meeting here? All right, looks like not. So we'll go ahead and end the meeting now. Enjoy the rest of your day. See you guys tomorrow.